In problem 5 on page 99, we are asked to make a market demand schedule for soft drinks. And remember what a demand schedule looks like. All it is something that looks like this, where we have a box, say, and in one column we have the price of a good, and then in another column we have the quantity demanded of that good at the price. So I'll just put quantity demanded at price. In this problem, we are given the demand at different prices of soft drinks for individuals, so individual consumers. And then we are asked for the market demand schedule. So this tells me that I'm going to have to consider the demand not of individuals, but of the entire market. So stepping back a second, let's break down the information the problem gives us step by step. We are told that at the price of $2, that an individual consumer will consume about 37 gallons of a soft drink, so say Coke. And at the price of $1.50, an individual consumer will consume about 50 gallons of, say, Coke, which is not surprising. Remember our law of demand, which tells us that if the price of a good decreases, all else held constant, we would expect more demanded. So I'm just going to put demand for Coke. I'm just going to make up a soft drink, and then I'm going to put price. Now, what we need to get to the market demand curve is exactly the piece of information that tells us what the population is, the US population. So they tell us the population is 294 million. And so all I really need to do now is to say, okay, well, if each individual is consuming 37 gallons at $2 a soft drink, then how much is the entire population consuming at $2? And similarly, if at $1.50, an individual is consuming on average 50 gallons, then how much is the entire population consuming? So all I really need to do is to first multiply. So let's consider the case where soft drinks are $2. At $2, all I really need to do is multiply 294 times, and we know this is in millions, times 37 gallons of soft drinks, and that gives me 10.88 billion gallons of soft drinks. At the price of $1.50, I'm going to multiply the population times the amount that a single individual on average will drink of soft drinks, which is 50 gallons. And multiplying that, I get 14.7 billion gallons of soft drinks. So really now all I need to do to fill in my demand schedule is just plug this information in. I just need to say, okay, at the price of $2, I'm going to have the quantity demanded be, this is how much the whole market will want to drink, 10.88 billion gallons. And at the price of $1.50, the whole market will demand 14.7 billion. And the problem doesn't ask us to, but we can think of our demand curve, which would just graphically represent our market demand schedule. So we'd have price here. This is our supply and demand model. And we would consider that at the price of $1.50 per gallon, of a soft drink, we have we have a demand in the neighborhood of 14.7 billion gallons, not in the neighborhood, exactly 14.7 given this problem. And then when the price goes up to $2, the population is going to demand 10.88 billion gallons of soft drinks. So we have 2 points. One is here, one is about here. And so given that market demand curve, market demand schedule, we might have a demand curve that looks like this. It's not a very pretty demand curve, but you get the point regardless.